Ashish Mishra, Group Director, SAC, who is the chair for this session. Dr. Chaitanya Giri, Space Emerging Tech Fellow, ORF, who is the moderator for this session. Mr. Arup Banerjee, who is the founder, CEO, Spectragaze. Mr. Pramod Kumar, SVP Engineering and Payloads. Mr. Suyash Singh, co-founder, CEO, Galaxeye. Mr. Ankit Bhateja, founder and director, Xovian Aerospace. Lieutenant Colonel, Lieutenant Colonel V. Ramanathan, VP Strategic, Liaison, KaleidEO. Now I would hand over the mic to our chair and moderator to go forward with the session.
Good afternoon to all. Let me welcome the panelists here, a very distinguished one, and of course the distinguished audience here. So before we start the discussion, let me tell briefly about where I come from. So as you see, I come from ISRO, Indian Space Research Organization, and particularly the unit which is Space Application Center in Ahmedabad. So Space Application Center, most of you may be knowing, but those who do not know, is responsible for the payloads. All the payloads that are going on board ISRO satellites are actually designed, developed in Space Application Center Ahmedabad, and then it goes to URSC Bangalore, where it gets integrated with the satellite and subsequently gets launched. And this covers all the domains, like from remote sensing to communication to navigation. In remote sensing, of course, microwave as well as electro-optical. And my background is of electro-optical payloads. Come September, I will be doing 35 years in this field in Space Application Center. And we are close to, on the cusp of almost 100 electro-optical sensors we will put in orbit in near future, and barring one or two, I've been part of all of them. So that's briefly about my background. And the time is really, the time that we are in right now is wonderful, subsequent to opening up the space for industry participation. Whatever doubts or skepticism at that time that were there is now, I'm sure it's all put to rest, the way things have picked up, taken up by the industry, the way things are happening there. It's very encouraging, and being represented by some of them here, but there are others also. So it's encouraging from the entire space ecosystem, I would say, in our country, but it's encouraging for ISRO also. All said and done, probably the kind of requirements, kind of demands that are there in the commercial domain or in the from the nation, ISRO might not have been able to meet, has not been meeting. Let me be frank, and would not have been able to meet those requirements. So this supplementing, complementing each other from the private space and ISRO will continue to, of course, be in this field, and its experience that they are there, I'm sure it will be very healthy for the industry also. So we expect to see a lot of collaborations between amongst the industry with ISRO, and we'll see how it goes ahead from here. So without taking more time, I think it will be better to carry on with the panel discussion. So what I would request my panelists to, one by one, I would request them to introduce themselves, give a brief of their company, and what have in few minutes something that they have done, they plan to do, and let's see from there we will take it up. Yeah, yeah. So welcome you all again. So let me request on that side. Okay, Pramod. Pramod, I know him. He was in Adrian. We had worked together some 10 till he left. There were in between we had been working together. So Pramod I know very well, but now where he is, let him tell about what he is doing. So yeah, Pramod, it's yours.
Thank you, Ashish, for the nice introduction. And I'm Pramod, so he has already mentioned I'm from ISRO background. So I worked in ISRO for 28 years and then came to XDLinx. I'm taking care of most of payload related as well as the head of engineering in XDLinx. So I'll first start with XDLinx, what we are and where we are, and then also touch upon what are the because the session demands this the discussion on payloads. So I'll touch upon the kind of payloads which we are into, and then what we are planning to make, and that's how I'll plan to put forward all these points. So XDLinx started in 2022, and we are 3 years old company now, and we have launched 2 nano satellites. One technology demonstrator with all the subsystems in place, and that worked for 6 months in space, and then the next one which we launched, the second one, which I'm going to talk about the payload as well, is a very special payload which we have posted, and that is launched in January from SpaceX, and that is still in the operations, and then we are conducting regular operations and receiving the telemetry and then doing the ConOps. So that is as far as the 2 nano satellites what we launched about, and as such XDLinx is basically a satellite bus provider. We have 5 standard platforms ranging from 10 kg to all the way up to 200 kg satellites, and yeah, we next coming 4 to 5 months we are planning to launch another 2 satellites, and all these satellites are customer-based satellites. One of it will be our own, and we have slated for another 4 launches next year, and in 3 years we are supposed to build at least another 20 satellites for different customers. So this is briefly about what XDLinx is about, and we are about 150 as of now. And yeah, so one of our satellite which we are co-building with Galaxeye is planned in the February 2026. So that is as far as what kind of size of payloads and satellites we build in ISRO, and thanks to all the technology and miniaturization that we are into a different era of what we are looking into payload as well as satellite technology. And the other payload which is in the advanced stage of development is when I'm talking about optical payloads basically, and this is 0.7 meter GSD, and its mass is we are targeting less than 30 kg, and this can be put in micro class of satellites, and it is as I said, it is very compact and very efficient and very low noise, and we are planning to have 5 to 7 bands of multispectral with 0.7 meter GSD. This is as far as the Earth observation optical payloads are concerned. Then I'll touch upon something. We are also into SDR, so we have our own SDR. So we are planning to have our own SIGINT and ELINT payload, which first phase we are planning to put 80 megahertz to 8 gigahertz. Right now the SDR is in place, so we are working on the RF front end. So 8 gigahertz or 8 to 18 gigahertz will take call based on the availability of the components and readiness of the technology itself. So that is as far as the ELINT side of the payloads are concerned. We are also working on the communication side. So as the other satellite which I talked about, which we launched, is the communication payload, which is a very unique payload. It is world's first miniaturized E-band payload which we launched, and this has the potential for, this is actually considered as the next generation communication band, and it will give you very high data rates of all the way up to 10 Gbps, and this is the first satellite which has been launched from space to be qualified in E-band. So this is the 3 kinds of payloads which we are working on, and we have a roadmap for getting into hyperspectral as well. That will be next year down the line. So that is in brief
Thank you, everyone. I'm Lieutenant Colonel Ramanathan. I'm an Indian Army veteran. I have served for around 21 years in the Army, out of which around 12 odd years has been in the field of satellite imagery interpretation, analysis, and drawing intelligence insights and inputs from that. So I am representing SatSure and KaleidEO. We together are a full stack Earth observation company, which starts from making the payload itself. Our payloads, we have two of them. Both are in the optical domain, electro-optical domain. One of them will be a wide swath imager, so that is giving a swath of 65 kilometers at 1 meter GSD, and the other one is a high resolution, further high resolution, super high resolution imager. So that will be a 16 kilometer swath with 0.5 meters or a 50 centimeter GSD. Both of them have achieved excellent results in their tests. We've carried out aerial testing of one of our products. And from here, that is the products from KaleidEO, we now hop on to launching them through a partner and deriving the analytics which will be generated from these, the images which will be generated from these payloads. So SatSure is going to turn 8 in this September, and we are around a combined strength of 170 odd employees together. We are in the process of our Series B right now, and yeah, so right now what we are doing is that we are majorly into the field of agriculture, agri-insurance, and agri-finance. Apart from that, so this is a core competency. We started this around 7 odd years ago, where we are connecting basically 3 dots, that is the farmer, the insurance company, as well as the banker together to give meaningful, a loan to the farmer to begin with, so that he can be independent and not get caught in the web of loan sharks. Now we have progressed from there. We are also in the aviation field. We have our program with Aviation Authority of India, AAI, as well as supported by DGCA, where we are digitizing the requirements of the ground support and the ground crew inside the airport. Next is we are also into utility segment, specifically in the power transmission lines, where we are trying to give out solutions on how to build a power transmission line and maintain it over a large distance. Additionally, we are also having a program with the Rajasthan state government, which is also sponsored by JICA, Japan International Cooperation Agency, and that is to do with the forestry, the Department of Rajasthan, and basically giving the health of the forest and even classification of the trees, be it eucalyptus or deodar or whatever be the case as it is the state-wise, and help the state government in analyzing the level of afforestation or deforestation as the case may be, and grouping of these trees together. We are also building solutions for the strategic and the defense customer, consumer of our country. That is my primary role in the company, where I am steering the products which we have for customized solutions for the defense market, and certainly Opsingur was one example where we have all seen that how well we have performed, and as a private company, as a private entity, and as a together as a consortium, how we can give it back to our country for better development and strength in the in our near Geo-Pacific area. That's all from me. Thank you.
Hello everyone, my name is Ankit. I'm from Xovian Aerospace. We are building a radio satellite infrastructure. My journey started in 2016-2017, where we launched India's first successful student satellite mission. This was a mission where we realized all the satellite subcomponents and systems that were required to build a satellite from scratch within an education institution. So that's how the journey started, and in 2019 we started Xovian Aerospace. We are at a pre-series stage currently, and what we are building is a RF satellite infrastructure where we are collecting radio frequencies from 30 megahertz to 18 gigahertz. So what we are doing here is that we are collecting different frequencies to track the movement of the assets, targeting maritime, aviation, defense sector, and also we process how these radio frequencies interact with the atmosphere. This gives us weather forecast information, total electron content, basically to observe what is happening in the upper atmosphere. So this is the overview of how the data sets look like and what we are collecting. Coming to the payload side, what we have ended up developing is multi-band antennas required for the payload, And the payload is essentially is a software-defined radio, which we have built in-house. And all the testings that we have done over a period of last 2 years, we have already qualified the payload for space launch. And there are 2 missions that we are targeting in upcoming 8 months. So how this infrastructure is going to work is it's a satellite constellation, and the data coming from it is provided to the customers with the help of a decision intelligence platform. So alpha run of this platform is already there with us. We are testing it with some of the customers. This is fully AI driven platform with a combination of onboard processing and cloud processing, where customers can directly get decision insights depending on the problems they are facing. For example, if I would like to tell one problem here, currently if we talk about maritime sector, there are 4 to 5 different data sets a company in maritime sector consumes. First one is the tracking of the ships. Second is the sea surface information. Third is weather forecast. Fourth is when a ship goes dark, you need another type of data. So what happens that a company ends up procuring 4 to 5 multiple data feeds, and then they need to process these data sets. So this entire process chain takes about 4.5 hours. So we are collecting all these data sets with the same hardware and processing it on board, thereby cutting down the latency to up to 15 to 20 minutes. So that's where one of the example use cases is. And similarly, we are targeting aviation, BFSI, and climate sector with the help of this hardware. Thank you so much.
Suyash? Yeah. First of all, thanks for having me here. I'm Suyash. Most of you know what Galaxeye is, and I think we've been repeatedly attending these conferences, so I will not go into too many details. Just to refresh, we are building a satellite which is world's first of its own kind, combining multiple payloads. Multispectral and SAR is the combination that we are going to try out. Our idea is very simple. We feel the single sensor satellites are done. The next generation of satellites are about to come up. NISAR is a great example. We are merging a couple of bands in SAR itself. Similarly, optical SAR is what we are trying. Maybe a bunch of other companies are going to try thermal hyperspectral and whatnot. I think the next generation will be more about how do you really blend a bunch of electromagnetic spectrum to come together to serve a specific problem of a kind. At Galaxeye, we are motivated to fix one very specific problem, right? We are not all over. We are not someone who is just trying to do everything. We are very specific to our problem statement, and that is just one word, SLAs, abbreviated as service level agreement. Service level agreement between a satellite data imagery provider today and a user is never honored. It could be cloudy, it could be nighttime. You may have 80% cloud cover in an optical image. You may not have an image during the nighttime. SAR is hardly interpretable, right? You really need a super PhD guy and, at least a well-trained guy to understand SAR. So So I think, in our opinion, imagery is hardly utilized, and our goal is to make the utilization of satellite imagery come up. Building a full stack ISR solution, which is more focused on defense and intelligence, as well as on commercial side. About the company, I think we started 2021. It's been 3 years, launching our satellite very soon. Just announced our launch date. So that's about it. Happy to answer more questions. I think just for the sake of this sort of panel's title, I may take a couple of minutes and discuss. It's an interesting panel if you kind of look at the title. It says Payload Pioneers, and then it also says Manufacturing Ecosystem. To put these two words in the same title, it's pretty interesting to think about it, right? Indian space ecosystem right now in the country is trying to hop onto 2 threads. Thread number 1 is how do we boost manufacturing and come up to the levels of exports how Western countries are doing, or Europe is doing, or whoever it is. We need to build an ecosystem in the country to boost manufacturing and copy paste and advance the technologies that West has built. Be it electro-optical, be it only SAR, be it RF, be it bus, be it launch vehicles, be it anything. It's kind of taking that capacity and making it in India, indigenizing. That is one thread that we are trying to follow, which is great, but will not work in the long term. I think we'll have to take the second thread as well in parallel. The second thread is about innovating. How do you innovate something in this country that is applicable to the larger world? How do you really export the technologies? Because if you're thinking that we'll build something here which has already been in the West, built in the West, and then you'll be able to export, I don't think that's going to happen. So what we really need to do is, how do we export what we are building here in the country? And I think to identify that, I'll touch base upon very quickly and, and take 30 seconds on and telling this. I was attending a conference in the US very recently called US GeoInt. And what came to my notice was, US is completely focused on building the highest resolution electro-optical satellite. They are trying to go up to 0.1 meters, 0.15 meters, which for us is going to be a longer run. If you think about Scandinavian countries or the European countries, the Finnish and other people have literally mastered SAR. And because they had to look through ice and that region of area, they mastered SAR. If you come to Japanese, or rather Koreans, they have mastered IR payloads, or thermal IR and SWIR and whatnot. I think all of these countries, if you kind of think through, US, NATO, Japanese, these are non-tropical countries. They have their specific requirement, which doesn't have clouds, right? And they are probably a little more trained than anyone else, right? So our surveillance requirements cannot be built in by saying, oh, there was a white paper written by some Western guy in the world, and okay, now I'm going to build a satellite that will cater to that requirement which a Western country has posed to us. I think we need to make an effort as payload pioneers to find out what exactly is required by India and Global South at large, and then cater to that demand. This is extremely important rather than coming from upstream. Oh, I'm going to build a facility, then I'm going to build a satellite, and then I will leave everything to the user on the downstream that I'm giving you this, you figure out the best way to analyze. It is not going to happen that way. You can throw any amount of data, but to be honest, on downstream, it's so hard. It's so hard to utilize data and make sense out of it, because satellite companies don't think that way. I think we need to reverse the trend. We can't come up saying, oh, I have these satellites, now you make the sense out of the data. We come from an engineering and a scientific background and say, oh, this is an interesting technology and let me attempt it. Data, somebody will take care of it, and AI, like we just say AI very loosely, AI will do all the jobs. See, it is impossible to do that. Even ChatGPT cannot read SAR. Trust me on that, right? So I'll probably end there. Dr. Giri, thank you so much for the opportunity, but I think we need to take these two threads. Manufacturing is one, which we are all thinking about it, but innovation is something that we are missing on, and we need to think about it. Golden Dome, and so on and so forth, we'll always be chasing them. We will never be leaving.
Dr. Banerjee. Hello. Hello everyone. I am Arup Banerjee. I actually come from ISRO. I did spend there 23 years of my life, and all these years I developed electro-optical payloads for almost all the missions that you hear about. I was part of, luckily. So right from the hyperspectral, pan-MX, thermal, and the high resolution stuff. And I was also lucky to be actually working on a key technology of electro-optical sensors, which is basically the detector systems. And development of indigenous development of detectors in ISRO was led by me for last almost 10 years. So I left ISRO in December 22, started a company called Spectragaze Systems primarily focusing in aspects of electro-optical payloads. Basically, I understand it this way that if you are to develop good quality data, if you are to develop good quality data that can actually compete with the people who are at the top, like Maxer and many others, you need to look at it in all aspects of payload rather than just focusing at the system level integration. So basically what I mean is that if you do not do imaging detectors, if you do not do development of optical telescope and its electronics and the data products altogether, if you don't do, then it really cannot make a good payload. So that was the intent, and that is how actually ISRO works actually. With that intent, I started this company where I develop my own detectors. And that is very important basically in the ecosystem. If you see today, there is no detector developer in the country. So we'll have our own detector development that is needed. So this is one of our vertical, and of course the payload and other things. We have over the years learned how to develop payloads and how to develop high resolution payloads. So that is basically the thought process. With that thought process, so we are in the journey today. We have started already building a couple of hyperspectral payloads we have developed, because I am the person started hyperspectral development in the country. You can say started from Chandrayaan one time hyperspectral development. So a couple of hyperspectral payloads already we have developed, and currently we are developing a hyperspectral payload for a CubeSat platform for one of the private companies. And we have actually a mission set actually that we are going to develop indigenously developed detectors and high resolution payloads for a constellation of satellites down to about 0.5 meter. And that will have, like Suyash was mentioning, that we should have actually array of sensors in these covering these spectral bands. Our motivation is to go from right from 0.4 micron to almost like 10 micron, cover the entire band using one particular telescope. It's not that something I am doing it for the first time in India. So naturally, if you see all our missions does that way only actually. It covers the entire spectrum. So I'm going to outside do that part and do it in a different way using our own detectors basically. So that is one thing, and then gradually this will be, because we'll have our own detectors, we are already in the job of making our detectors. So we gradually want to take one more step ahead actually. So in the world today, people are talking about high resolution, hyperspectral and high resolution, multispectral and superspectral and all that. So what we aim is to do, develop hyperspectral sensors down to about 1 meter and 0.5 meter, which is a basically game-changing hyperspectral. It requires technologies of various kinds actually, putting together high sensitive detector system, large optical payloads, and of course the filter technology, putting together these band separation aspects, put together about 5 or 6 different new elements has to come, because this technology is not available. We are ready and we are gearing up, and we are already started development. You will soon see we are gearing up for about 0.5 meter hyperspectral in the country.
Among all these functioning payloads, I am the dud payload. I have nothing to talk about, at least at this point in time. But yes, I've had a history of working on measurements and signals intelligence back in the days during my PhD, some more than 10 years ago. It's very invigorating for me to moderate this session. It is exactly like a movie where the credit roll comes very much close to the interval. It's almost halfway through, and I'm introducing myself as the moderator of this session. So, since they have so eloquently introduced themselves, let me, with your kind permission, sir, let me start asking questions, basic questions. You've been dealing day in and day out in developing something that none in India have attempted, except ISRO. And this is a fairly nascent market, a new market. You're entering into newer horizons. And while you do that, there are 2-3 major issues that come up very often in today's times. One is, of course, the supply chain. If you talk about manufacturing, where is the raw material coming from? Where are the components coming from? So quickly, I may want to ask you all. Are you facing any challenges when it comes to components? Where are you sourcing it from? Is the government concerned about the origins, the provenances of these components?
Yeah, thank you. Thanks for the question. Actually, there's a very valid and very painful question which is very difficult to answer.
That's the perk of coming late.
Okay, so put it plain. Most of the components like for instance we are dependent on the chips and ICs and FPGAs, and even Arup has mentioned is working very. He's really working on the cutting edge thing to get detectors as well. So as far as we are concerned, we are dependent on ICs, FPGAs, processors, and then the detectors. So these are the raw materials we do import, and most of the electronics is we do in-house. Definitely, when it comes to the supply chain management, is a big problem, and it is all affected by even the geopolitical situation. A small trigger of one event will put your entire supply chain on. And we are working on a committed deadlines and the schedules. Even the launch is fixed, but if some instance of this one gets triggered or anything goes bad, then entire program mission goes for a big loss. So supply chain management is a big challenge we are facing, and it is all driven by global market, global instances. All this is good. As the topic is aptly said, it should be, if the entire ecosystem is within India, and then if we have control within the country, it will ease a lot of things. Yeah, but at the same time, another thing which I was also trying to explain is the deadline based. When you have a deadline based targets, and then and of course if we are dealing with customers like Government of India, where the procedures come into picture, and also the processes take time, and this puts a big hurdle for us. Unless you commit to the supplier that I am going to place so and so, or I need it so and so, he is not going to work on it. He is not going to deliver the product. Right? So these are some challenges which we always face in the industry. Yeah. So but we have to deal with it.
Ramanathan?
I'll fully agree with Mr. Pramod. The ecosystem in India is right now at a very nascent stage, and we are at a phase where we need to meet deadlines, and specifically the government deadlines. There is also, I think, a matter of point in identifying proper, partnerships with trusted countries, trusted partners overseas. Because I think somebody has matured their local ecosystem, their local market in a particular niche technology. If we start building everything from scratch, naturally the timelines on that are not going to be met. And so hence we need a system where initially at this phase, where we are as a country and as a community, we do depend on trusted partners in the overseas. But however, on the same breath, these partnerships and these components which need to be integrated while making the payload need to be kept at the bare minimum. Whatever maximum possible which can be made in-house should be made here, which we are also trying as a company. And yeah, of course, most of the guys in the team, they are burning midnight oil in trying to meet these deadlines and get the supplies coming through. We also have a lot of issues in the customs thing. It's not a very open market where you order something and it is going to immediately flow into you. Customs is a big hurdle, I think, as far as this meeting the deadlines are concerned. So somewhere, yes, these challenges are there. As a company, we are trying to make the best out of it. Whatever we can do it in-house, yes. But otherwise, we have our trusted partners with whom we are dealing.
In a few words, can you mention what are the problems or hurdles with customs?
Primarily speaking, it's the amount of custom tax which they are imposing on us. Like for example, it can't be equated to me ordering something personally for myself from, in a not so friendly country. We all know those platforms which are now switched off in our side. But in this case, if it is proven that it is an equipment which is for a research purpose or for a greater good purpose, or let's say a government, something which has to go into the nation building, if I can use that word together. That is something which needs to be probably a separate chapter in customs itself. Otherwise, what happens is right now that we are all dealt equally in all these things. In fact, one of our payloads is, as I speak, it is stuck in customs somewhere. So that is a challenge which we are facing. And for these things, I think there should be some exclusivity. There has to be some more outreach which needs to be there. If the time, because we are all aware, even for importing something as small as an IC, it may get stuck at the wrong time. It may even take months for you to recover it out, even after paying the money, even after paying the taxes for not the money. So that's the thing. So primarily speaking, if they can reduce the custom fares and make it somewhere reachable, we are all a startup ecosystem. The big wigs may not really have a problem in getting through. They may have a parallel ecosystem running which is helping them through in this, but for us it is certainly a little bit of a challenge.
Ankit, over to you.
So specifically 3 areas where we have seen challenges over last few years. First one is antenna material. That is one of the areas, because space grade antenna materials is not something that you easily get in India. That's where the issue is, and since the application that we have is dual use and defense application is there, then the end use certificate and utilization, that takes a lot of time in order to coordinate with the foreign partners. Second is software defined radio, which we have indigenously developed. The challenge that we faced initially was the fabrication of that, because currently in India most of the software defined radios are either being used by military for military use cases, and second is like for communication in the satellite. So R is more of like a software defined radio being used for a standardized bus platform as a payload. So we had to design that miniaturized software defined radio, but the fabrication issues were in a way that the vendors we had tie-ups with in India, the fabrication issues, particularly in terms of what kind of facilities they have available, were there. So we ended up getting that fabricated in Taiwan. So after the fabrication, again the customs issue came, and first one we got cleared. Second one, the shipment came on 28th May. It is still with customs. We had to submit detailed PDF write-ups, like what exactly it is, what is the bandwidth, what sort of data it is going to transmit, or what kind of inputs we are going to take. So all these things we have to explain. But the issue is that the person who is handling these things in the customs, he is not something who is aware of technology. And at the same time, these things are new, so they are not aware of what exactly this kind of system is. So that is where the problem lies. And third one is basically related to the calibration data sets. So particularly in signals intelligence applications, because the use case is defense related, so the challenge is to get the calibration data sets for your own hardware. So that is another challenge that we face. So ultimately we ended up developing our own on-ground system to collect the data and then use it as a calibration model to train further the payload site data sets. So these are certain challenges. And apart from that, the custom duty again, because there was a recent notification that if you are importing satellite component, custom duty 0 was there. But now when you go to custom department, they are not aware of this change. So you need to first tell them, and then they tell that we have not received any such notification which says so. So that's why some inter-department maybe coordination issue is there, through which this notification needs to first go to customs, then only they will allow that. And how do you categorize a satellite component? Because software defined radio can be categorized as a telecom component as well. So how do we define that category where you say that this is a satellite component? So this is something I think which needs to be taken care of in order to address that zero import duty on satellite components. That's it.
Thank you. Suyash?
I think everything is probably already covered, right? So I don't have to repeat what they've said. But just to add on to, I think the intention probably, to improve the scenario, we need to be a little more risk taking. I think we have to think about how can we take more risks, number one. And I'll tell you an example, right? When we started Galaxeye back in 2021, 2022 XDLinx was started, right? they only launched a Xanos kind of satellite, which was pretty small. We gave them an order of building a 150 kg class satellite. Right? If we would have also gone in the ways that I will give you a PSQR and all of those things, right? It would have taken at least 3, 4, 5 years for us to trust them to build something like this. Right? And I think they have to trust us, we have to trust them. Indian ecosystem has to start trusting each other and start engaging in those large transactions. Plus, the authorities have to soften their QRs, to be honest. If they can't provide the testing facilities, they should not ask for those QRs.
Who are the people making the QRs?
Authorities. We all know DOS, DOD and whatnot. The point is, whoever is making the QR, they have to understand if you are going to privatize the ecosystem, not everything can be built in their facilities. They will have to import, right? If you need the best quality on day one, you'll have to import. If you can manage with a little bit of quality, you can actually innovate. And the innovation would mean, let's say I want to make a CFRP component. Can I go to an automobile manufacturer which is really, really established as an industry in the country? And can I ask them to make the automobile components into space? Take a little bit of risk, think through, not thinking about, it was written somewhere in the past that it has to be A grade, B grade, this license, that license and whatnot. I think we need to start taking a little more risks in doing things. Otherwise, this is going to be like super slow, right? Probably when we took the risk, we have taken the risk of building SAR from scratch in the country. I think a lot of people came and discouraged, don't build. You cannot build, you're just a bunch of IIT Madras graduates, you can't do that. We have built it. We have built the best SAR in the country. In fact, probably the best SAR drone based in the world. And we are going to take it to space very soon. So all of these things will only come by taking more risks. And that is what is probably missing in our supply chain improvement thought process beyond what challenges have been posed by these gentlemen.
So I think I want to couple of things actually, very important questions though about the supply chain. So I all the time in my ISRO career faced this particular challenge because whenever it comes to a very key technology, be it optical payload or otherwise also anything, right? Primarily I come from optical payload, so I would give that example only. So all the key elements, primarily the detectors, they are very costly actually, detectors. And they decide what is the cost of your payload primarily. So I see it that way. If we are actually looking for development of a constellation, a large constellation and a successful constellation, then we cannot rely actually on foreign sources. It's impossible actually. In a way, what I'm saying that if you are making 1 or 2 satellites trying to prove yourself, kind of a proof of concept type of, then it's fair actually. Nobody is going to object. Nobody is going to, basically create any trouble. You imagine a situation where you are making payload which is the class of Maxar, and it starts generating data at that level where you had started selling data to US or Canada or any other company or any other country in the world. So obviously what will happen, your components, key components will not be given as easily as you will imagine actually. First thing it will happen, your cost, at which you are buying, you cannot even compete also. So your cost is to start with. Now also when you are doing POC, your costs are at a much higher level. And then when you start competing with, then you may, because of the we're discussing, right, because of the geopolitical situation. Geopolitical situation is so volatile, right? So you put a constellation of the class of Maxar, maybe it is like 5,000 CR project. You start spending money like anything because for building a satellite constellation of that, all sides you have to start putting money actually. And then you see your key components coming, let's say 2 years down the line it is coming. So if it gets delayed by half year, 1 year, 2 years, what happens? Because each of these key components, they come with export license. They are dual technology uses, they come with export license actually. And there are certain segment of products like PAN, MX, they are basically easier to get, but still having like about 7-8 months of just export clearances only. But go to other technologies like the infrared bands and all that, where defense is actually nighttime imaging and all that. If you are looking for, there is no clarity at all actually. How do you get that product actually? So in a way I'm saying that if you are really trying to get into a situation where you will consistently make payloads, consistently make missions, and you will serve the country and you will serve the rest of the world, you cannot just focus only on the system development. Components are something which needs to be focused, and industry has to look at it. And component development, both the government as well as industry put together, the thrust area should be very well defined, that we cannot focus only on the system development and be successful and get all the, basically a big part of the revenue. It's not really, I don't see it as a possibility.
Since we are about to come to an end of this session, I'll go again for one last final round of question. Very quickly, what you see today is that, okay, let me give you an example. India has a very high import dependency when it comes to analytical equipments of all kinds. Whatever is categorized as HSN code number 88, we have dependency which goes more than 90%. So tomorrow, in case of any conflict, in case of any trade war, the chances are that countries who we may assume as part of our friend-shored alliance may not want to give us that particular set of technologies or set of equipments. And that means a lot of your R&D may come crippling down to a standstill. In this case, and I've always believed that, because I worked on something which got translated from a space-based equipment to a nuclear submarine-based equipment. What I've always found that there is always a way out for any kind of payload. Have you all figured out whether there is a way out to come from space to any terrestrial application for the technology that you've been using?
Hello? Yeah. So yeah, of course, that's a very valid point. Always we have to look for the alternative segments or the domains in which you can actually closely relate. One of the closest industry which we relate, mostly even for the space, most of this current nano as well as micro satellite or small satellite, let me put it this way, the biggest revolution has come from using the industrial grade and mill grade component, which most of the things are used in automobile industry. So this is one of the closest segment which we can correlate to and use most of these components from that industry, and use that re-engineer or do tweaking and do some kind of upscreening or even kind of qualify it for your space environment. That is where that's what we have been doing all the time. And yeah, this is one of the domains or the industries where we can fall back onto and then get these components from that.
Regarding, let's say, the question is that coming down from space, if you want to do it closer down to the Earth, in the electro-optical domain of Earth observation, and specifically to say in the in the domain of generating actionable intelligence for defense. To some extent, this is already going on. After all, we are an interdependent set of people. So, for example, if we are drawing intelligence from satellite imagery, that can certainly be done through drones as well. And the word drones is actually very misleading. It could start from a quad to a hexa to the fixed wings, taking off in a runway, taking off through a catapult, getting back on a runway, down from a parachute, and the different kind of payloads which can come onto it. So a classical example is the drones, which can be integrated, which are already being integrated into it. But there is just one catch with the drones, and that is that in the normal scenario, in the normal times, it cannot cross over your boundary. That is the biggest challenge against a drone. Whereas a satellite doesn't have a classical boundary which it needs to respect, or it cannot transcend. So yes, in the times of where we need to defend ourselves, of course, in those times, these two scenarios where a satellite as well as a drone can be are interlinked. There are plans on it. You're all aware. We've just recently seen it a month or two ago, where drones are equally well used into getting this technology along with us.
So two parts in this. First one is coming to entire infrastructure for collecting the data. It can be obviously made to suit with the ground-based applications as well, and we are already in discussions with some of the players who want to use such kind of technology from ground, because it is possible to collect this type of data from ground as well. Second is in terms of specific hardware modules or components. Let's take example for software-defined radio. So this is something which we can easily, develop as a COTS component and get it radiation hardened. So that is one of the scenarios which we can do in India only. Second is on the second component is the antenna material. That's where the biggest problem is. So what we have seen is that there are a lot of projects that are going on in silos within the ISRO departments, and there also they need to develop multiple antennas for different missions, and they do have some capacity to develop few antennas which can be used in their own satellites. So that also we have identified over a period of last few years, and we are seeing that if that capacity is given to industry in some way, not to startups but already established industry players, so that is one of the ways where this problem can also be solved. So this is how we are addressing the issues parallelly to see how this thing can be addressed in long term.
So again, adding to the discussion, whatever these guys said, plus I think innovate, right? I think the simple answer is innovate. ChatGPT, $100 million, DeepSeek, $5 million. What happened? They didn't have the GPU infrastructure. Innovate. When we built Hyperloop, we didn't have the rare earth materials to levitate, right? We were not having the, we didn't have the temperature infrastructure to have magnetic levitation for sub-zero temperatures and whatnot. We innovated. We built the Hyperloop system, which is working, inaugurated by the Railways Minister himself. I think the key question is how hard, how you are driven to innovate. DeepSeek is a great example with the kind of funding that they had, with the kind of innovation that they had. 100 million brought down to 5 10. Similarly, I think all of these ideas are great. Using automobile infra, CalVal, ground infrastructure, so on and so forth. You could be not the best product on day one, right? But slowly and gradually you'll reach there. I think we need to find our own ways to survive, right? And of course, at the same time, we need to have better geopolitical relationships, and ramping up on that even more and more often is certainly very crucial.
So I think I would like to just add mostly everything talked about. I would like to add just one point that see, as such, the technologies that are used in our terrestrial environment, they are not to be thought as they are lagging behind or anything. Actually, they are most advanced technologies, probably maybe 1 decade at least ahead actually. So when the technology gets matured, then only it actually taken into space. Actually, it's other way, because we think that way the space technology is supposed to be very advanced, and then it's not that way actually. The most mature technology is taken, and the simple reason behind is that you cannot simply take a technology to space and spend, let's say, about 500 CR actually. You need to be very sure about that, nuances of these things and how it can go wrong, and how it will actually work in the environment. So, so many of the things have changed, many of these things, because of this new space coming, where low-cost space technologies, CubeSats and very nanosats and other things are coming. Things are changing, but then CubeSats and nanosats, they have their purposes. They will continue to remain there, but there are other satellites, which are the microsats and also the bigger satellites. No, they will continue to be there, and for those, the space components will also remain separate only. You cannot actually take a commercial grade, put it into a space hardware that will have, let's say, about 1000 CR project. No, it can't happen that way. So there are two separate segments. They will have their own business, and they will continue and flourish separately. The one which is there, the niche and the very high value, the defense or maybe Earth observation for the civilian application, they will have the very high-end sophisticated space hardware, which is space grade and very costly. And the other one is the commercial, very commercial, the low cheap, the new space will also flourish. It will have its own business, and that way both things will continue.
Thank you. Thank you so much. We have another 5 minutes for quick Q&A with the panelists. Anybody who has questions? Yes, sir. So please introduce yourself.
Hi, check. Yeah. Hi, myself Shashank. I am from KaleidEO Space System. So I have in particular two questions. So first is to Suyash. So as he highlighted that innovation is the key. So I would like to ask him, what is his experience, or if I may say so, experience so far when it comes to innovation, considering the funding, the ecosystem, how much the ecosystem is ready, the talent pool, and also a couple of other factors. For example, this when it comes to the government as a customer, so stringent deadlines, and the heritage altogether. Because whenever you innovate, you know how the things go on. You have to consider all this. And the second question is to Mr. Arup. So when you talk about detector development, could you please elaborate? Is it on the detector system level, device level, or the circuit level? What we are talking about as of now? Because we, as the entire nation, we lag really in terms of, we don't have, if I may say so, the fab facility itself within the India. So how pose or where do we stand as of now in these factors?
Do we have any other questions? Anybody? Before I give it to the panelists? Okay.
Yeah, I was expecting this question actually to somebody to ask. So it's good that you have asked. By the way, let me put it very clearly that ISRO has been developing all its detectors basically for the last 30 plus years. And let's be very clear that if you are to actually look at optical payload development or any mission, right, you have to be always at the forefront, right? You have to lead, and that's what ISRO has been doing actually. ISRO has been not like somebody else is doing, and then we also develop the same thing. It's not at all possible actually. So all the private companies who are basically coming up, they should also think, right, how will I be able to make a product which is better than, let's say, Planet, or make a products which are better than somebody else actually. For that to happen, detector and as well as many other components have to be developed. Now coming to your precise question, as I said, no, ISRO has been developing detector for last 30 years actually. In the country, we had, along with ISRO, SCL as one of the organization where we used to source one part of the detector basically. Some detector, they make those detectors, it works excellent actually. But then that is not enough because ISRO is covering the entire electromagnetic spectrum. So we work with many other agencies. Name agency we work with actually in ISRO. And we have a good partnership created, and that way all our missions, like you imagine that 9 out of 10 missions are custom development of detectors. And like over the last 10 years, ISRO is developing its own detectors also. So it develops detector at SCL, it develops detector at other foundries also. So when the question is, if it is to me what I am doing, actually from end to end, I was leading a team for detector development within ISRO. It's basically an end-to-end development, right from the specification at the system level to basically doing front-end designing, back-end designing, package designing, filter designing, assembly, screening, qualification, and going up to that level. That's what I am planning to do actually. But the question comes whether I can fabricate the thing also. Yeah, no, that's not a possibility, and I will not even dream in, let's say, next 5 years. It's not possible. But then that's how it is actually. If you see that the US developing their own detectors, or maybe some other company, France developing, they don't actually fabricate their. And all the NASA detectors, whatever is developed, no, they either developed at Israel or they developed at ST Micro France, or maybe France developing detectors in Israel. Such things keep on. I mean, even for that matter, actually, Chinese detectors are mostly developed in Israel only. So that way it will continue even for us.
Yeah, just adding to one thing. So I assume these detector development is not open to public, right? So whatever going through the ISRO.
No, it is open.
So,
it's
okay.
open.
So as a private player, we can ask.
Yeah, it is. Like as I said, no, I am into detector development. I am developing detectors for the private players for my own consumption. Even I am attempting to actually develop detector for ISRO also.
Okay, great. Thank you. Good to know that.
Awesome. Now, I think coming to your question towards me, see, from an innovation standpoint, funding talent ecosystem, let's take the example of US. SpaceX, when it started, probably NASA was the only place. Today, ISRO is the only place, from where you may be able to find talent. And I think companies like yourself, ourselves, and many others in this industry have found ways to connect to relevant ISRO talent pool, be it from an advisory format or whatever format. I think that's probably going to evolve in the future. It is also interesting to see a lot of our employees have returned from the US. They've studied in the US and they came and joined us. Probably it's around 20-25% people who have now done some MS and PhD in the US and they're coming back. It's about the quality of work that you're going to offer to the talent, then they're going to be motivated, right? Then I think a normal notion or common notion is in India we're going to do e-commerce, 10-minute delivery, 5-minute delivery and whatnot. And hence the top tier talent is trying to get an MS admission in a US university and then trying to find a job. Thankfully to the geopolitical situation, they're not getting jobs there. Right. So it's an opportunity for us to kind of bring them back. Right. Now at what price point, I'll leave that to the company specific and stuff. I think innovation, funding, again, it's a broad subject, depends on how an ROI can be made, etc. How government will play, I think we do like dime a dozen panel a month on that, on funding and whatnot. I don't want to speak on that. But I think the key thought process is we'll have to find ways super quick and super fast in data processing to detectors to everywhere, and we have to be nimble and we have to be risk takers and we have to be appreciative of a new risk that is being taken, right? To tell plainly, I think in the last conference I attended, one of the guys said, everyone knows that SAR looks at an angle and optical looks at another. To be honest, I'll tell you very plainly, I've never seen a multispectral at another. So who is this gentleman who has spreaded the word that optical looks at another and SAR looks of another? I don't know who is this guy. This is discouraging a particular innovation in the country.
Precisely, that's the point. That's what I was aiming to. In fact, I was also a decade spent my time in Europe, and I was working for NASA and German Space Agency together with Israeli. And the approach over there was quite different. What I am seeing over here. So I'm really struggling with them, trying to understand the ecosystem, but thankful to these panels and the people over here. I think so. There's a lot of opportunity, and of course there is the way to go around. So yeah, thanks.
Thank you very much, panel. I'll hand over to the honorable chair, sir.
It's been fascinating really to hear them all. It's a pity I was thinking that should I not have been sitting in his chair and asking questions and discussing with them. And the time has really passed so quickly that it's sort of we have warmed up and things are finishing. So yeah, the challenges are many, but there were more, I guess, 2-3 years back when the space really got opened up for Indian industry. Like Suyash said, that you have to find your own way. There will be hurdles. Things will not change for good overnight, but you have to be optimistic. You have to be at it. I understand from ISRO, coming from ISRO, where you are actually backed up by government, and it doesn't really, it hurts, but not the way it hurt you people. So, but yeah, we would have gone with the discussions, but I'm sure there will be, I would have liked to ask some long-term visions, that you are starting off the Indian space segment with what, and good that all domains are sort of covered here, whether it is communication or intelligence, GEOINT also, and of course SAR and optical payloads and all. A foundry is an issue, but there is also, that is also, it will also take time. It's not going to happen in a hurry, but it will happen. It will happen. Till that time, Shway said we cannot go that slow, but I don't know what else, what other options do you have. You have to be at it, wait for things to happen. If you, Ankit, like Ankit was saying, if you get stuck somewhere, there is no other go. But so you have to probably get all those things, the possible hurdles. It's one good thing is that it's not we are unaware about those things, where you can get stuck, where the difficulties are. So if we have taken accounted for those things, maybe it will be easier for you people to navigate. Coming back to, I would have probably preferred to ask another question there, is that how do you what do you expect really after 2-3 years within space and all coming, all goes, but what do you expect ISRO to do that may help? One probably my own interactions with the industry, several people, I find that one of the areas is testing of the instruments that you build, because somebody said also that it's quite, investment is pretty tall when test, as far as test equipments goes, and takes time also, and ISRO with so many years behind it has them all. So that is one area, and people are seeking out, they are coming to ISRO to do this, and we are open to it. We are open to it, only how do we synchronize, because after all the ISRO facilities are limited there also. So you will be appreciating that it cannot happen at the cost of we not doing our job. So we have to somehow manage to walk the road together there. But that is one area where I think ISRO can definitely in a position to help. Rest, I think, it's in good hands, I would say. I will end here by saying it's in good hands. It's really thanks to the government of India that it really decided to open it up and provide the opportunities, and probably it will bring back people as they see that the saplings are coming out. They see the possibilities. People will start, the brains will be coming back here, and money will also probably come along with them, and so things will be much easier. Another thing which I'll leave for you people to think, which we faced, that we made the instruments, but the downward chain was sort of absent. The handshake was probably not there. So I hope that when people are doing this, you have taken care of the end-to-end, at least thought it out. You have partnerships with the right kind of people to make sure that what you do actually goes to the end point, and that's only that is how only you will be able to succeed in the endeavors that you have taken up. So wishing you all the best, and to the other also industries who are in space, let me wish them best. Thank you so much for being with us.
As a token of gratitude and appreciation, we now present mementos to our eminent speakers. May I now request Mr. Ashish Mishra to present memento to Dr. Chaitanya Giri. To Arup Banerjee. To Mr. Pramod Kumar. To Mr. Suyash Singh. To Mr. Ankit. And to Lieutenant General V. Ramanathan. Now I would request Rajiv Gambhir, Deputy DG SIA-INDIA, to present memento to the chair of the session, Mr. Ashish Mishra. Mr. Rajit. Now I would request everyone to step forward and for the group photo. With this, we come to the end of today's session. On behalf of the entire organization team, I extend my sincere thanks to all our speakers, dignitaries, and each one of you in the audience for your active participation and presence throughout the day. We look forward to welcoming you all again tomorrow, 26 June 2025, for another day filled with insightful session and engaging discussion. Please join us sharp at 11 here in this hall. Thank you again for your wonderful, have the wonderful evening.